we are going to discuss about the combined statement, connectivities, conjunction, disjunction, implication, by implication. These definitions we are going to discuss in this video. Now, the first definition is combined statement. The combined statement means two statements combined by the connectivities. Then the resulting statement is called combined statement. The resulting statement is called combined statement. Now, in this we use the word connectivities. We used the word connectivities. What are connectivities? Two statements we can connect by the connectivities. Those connectivities we can write it as connectivities. Connectivities. Yes, these are, we can write, yes, and, or, if then, if, and, only, if. Two or more statements or two statements we can connect by these connectivities, that is this and, or, if then, if and only if. First, let us will see here. This is, we can write the symbol for this connectivity. We can write the symbol is conjunction. This is disjunction. This one is implication. This one is nothing but symbol is by implication. By implication. Now, let us, we are using, by using an example, we discuss these. That is, let us see here one of the example 1. Now, P is the statement that we are writing. 2 is a prime number. 2 is a prime number. And Q is the statement. 2, 3 is an odd number. Odd number. Yes, number. Now let us take this an example here. The combined statement, we want to connect these two statements P and Q with connectivity. We'll discuss here P and Q. This is nothing but we can write it as P and Q means it is nothing but we'll get in wordings we can write P and Q. That is, we'll get P means is nothing but 2 is a prime number. And 3 is an odd number. Let us see here. This is nothing but P and Q. We can define it as P conjunction Q. Define it as P and Q. This is the combined statement. We can write it as 2 is a prime number and 3 is an odd number. One more example, same here. This is one combined statement. Second, one more combined statement. If suppose P implies Q, then the combined statement we can write it as if Q happens, P happens, then Q happens. Then we can write then Q happens. That is, if P happens means if 2 is a prime number, then Q is and 3 is an, Q means it's nothing but 3 is an odd number. These are the 1 to 2 combined statement we have written by using these two statements. Combined statements we can divide into these four categories: conjunction, disjunction, implication, by implication. Conjunction, disjunction, implication, by implication. Now the symbol for the conjunction we can write, this is symbol. Disjunction symbol is just V shape. You can remember the conjunction means the in wordings we can write and means here that's just present in both first statement and second statement. It accepts the both statements. And or, this is nothing but a V shape, or you can use remember it as a union type, union, and this is nothing but word connectivity or. Implication symbol, we can use this symbol, and connectivity is nothing but if then. Next, by implication is a symbol, this is a symbol, and this is if and only if and only if. Now we'll discuss briefly about the one statement, combined statement. That is, first of all, first definition. We are going to discuss the first definition, that is nothing but conjunction. Conjunction. Now here conjunction means same, we can define two or more statements, two statements connected by the connectivity Let here the connectivity is nothing but connectivity and is then the resulting statement is called conjunction. One of example for the conjunction, first of all, let's consider here P, Q, or any two statements, then the combined statement, then the conjunction of two statements denoted by P conjunction Q. Right. Conjunction. Let's consider the first statement. 4 is an even number. The statement Q, another one more statement. 6 is divisible by 12. 6 is divisible by 12. Let the combined statement, the conjunction, we can write it is a combined statement connected by the connectivity and P and Q, or this is nothing but we'll get P and Q is a combined statement. By the symbol we can define it as P conjunction Q. We can write here this is 4 is an even number, and 6 is divisible by 12. 6 is divisible by 12. Now, let us consider the result of this statement. 4 is an even number. Means it is a true statement. 6 is divisible by 12. 12 is divisible by 6. 6 is not divisible by 12. So that is nothing but we can say this is false statement. Reason 4, 6 is divisible by 12. 12 divisible by 6, but not 6 divisible by 12. Now let us combine statement of these two by combining connectivity, and if this is true and this is true, both are true, then the resulting statement becomes true. Otherwise, the statement becomes false. The result of the combined statement becomes false. This we can decide by using the truth table of this combined statement. We'll go for the truth table for the conjunction. Truth table for the conjunction. We can define first P statement, Q statement, and its combined statement. Let's consider here P is an truth statement, Q is truth statement. The result of this statement we need to discuss. Here, one of example we are writing. We are taking the example Ravi passed in mathematics, and second Q is another statement. Ravi passed in the physics. Third combined statement is nothing but delegate. He passed mathematics and physics. That means he passed out the examination. That means combined statement, if both passed, then he passed the examination. We'll go for the next statement. True. Let's consider next case. False. Ravi passed mathematics and Ravi failed in physics. In final result, P and Q. Conjunction means P and Q. He passed only one of the subject. One of the subject means he doesn't clear all the subjects, means he failed the examination. Next, we'll go for the third case. First statement false, second statement true. Now the combined statement we need to discuss with the same example. Ravi failed mathematics, and the same person passed in physics. The final combined result P and Q means if he passed in both examination, the resulting statement is false. That is nothing but he fails in final examination. Again, one more example I can write. He failed. Suppose he failed in mathematics, he failed in physics, then the result of the final examination P and Q means he failed in both examination, means resulting statement is the false statement. You'll get. That is nothing but he failed in example. One of example, we can take this example to write the truth table result of the combined conjunction. And one more method of writing is nothing but by using the circuit diagram. Let us consider here it is nothing but the P, this is nothing but I'll get P, and this is nothing but let's consider we are taking the second statement as with two switches. You are perfect in the physics than the mathematics, so you can write this result. We can by using this diagram you can decide the final result directly. Let us see here, suppose P closed means true statement and open means false statement. Closed means a switch, closed means true statement, switch open means false statement. Let us will see here, again same we are discussing. P is a correct statement, closed, and Q is a correct statement, closed. If both are closed, the current passes from the starting to ending. Current transfers means what? The resulting statement is true. Now let us consider here the second example that will decide the result. P true means closed and Q failed means is nothing but it is open. It is connected by the series combination. So only the current it passes up to P but not to the ending of the Q. So the current does not reach us outside, means we can say this is the false statement. Current doesn't pass us, so we can say false statement. Let us will go for the third case here. P open statement, that is nothing but I'll get this is open, and Q is true. True means is nothing but closed. So the current doesn't pass us because connected by the series combination. Now this one more next last case we'll see here. P opened and P failed. Open and last case here, P failed and Q failed. Means P opened and Q opened. That means you can say this current doesn't pass us from one end to other end. Means this is the best example. We can decide the combined result whether it is true or false in the conjunction form. These conjunction we can consider by using the Venn diagram. Let's consider P is one of the statement, Q is another one more statement. P conjunction Q. P conjunction Q denotes the space of the intersection part. P and Q both happens, means it is nothing but shaded by the region of the P and Q, that is nothing but common statement. This is P and Q, or we can write P conjunction Q. Conjunction, the combined statement with connected by the connectivity. The combined statement with connected, which is connected by the combined statement with the connectivity. With the connectivity, we'll discuss or connectivity, or is, we can write it as, is called dissection. Yes, let's consider here this is P comma Q are any two statements, then this dissection denoted by dissection of P and Q. Dissection of P comma Q is denoted by P conjunction P dissection Q or P or Q. P dissection Q or P or Q. Let's consider one of example X. Example 1. P is 2 plus 3 is equals to 7, and Q is 2 into 4 is equals to 8. That is, we are writing the combined statement P dissection Q is equals to P or Q, we can define this as P is nothing but, let's consider here 2 plus 4 is equals to 7, or 2 into 4 is equals to 8. This is nothing but combined statement. Let's consider individual results. First statement with 2 plus 3 will get 7. Is it 7? No, it is 6. So false statement, sorry. This is false statement. 2 into 4 is equals to 8. This is accepted. That is nothing but true statement. Now we need to discuss the final result of the combined statement. Final result of the combined statement. 2 plus 4 is equals to 7, or 2 into 4 is equals to 8. Or means any of these both, any of these two is true, then the resulting statement is true. That means you can say final statement is nothing but we can write true. Either of this true is, then the resulting statement finally it is true. We can discuss this, we can understood by using the truth table. Let's consider here truth table for dissection. Now let's consider here P and Q are two statements. P and Q are two statements. Their dissection is P dissection Q. The resulting statement P true, Q true, P or Q is true statement. And next after that, true, false, the resulting statement is true. And next again, we can write false, true, the resulting statement is true. Finally, we can write false, false, the final statement is false. This we can discuss by using the physics, by using the physics concept, circuit diagrams. In the two switches connected by the parallel connectivities. Two switches connected by the parallel connectivity. First switch, we are taking P switch here, and second Q switch. Both are connected by the parallel connectivity. Now let us discuss the result of this. P switch true means closed. Q switch means closed. If both are closed, the current from starting to ending passes. Means we can say the final result is nothing but true. And again, P switch is next case. The second case we'll discuss by using circuit. Now here P is true, P switch closed, Q switch open. One of the switch is closed, then the current passes from that line. So from starting to ending, the current passes means we can consider the result is true statement. Now final combined statement is true. First switch, P switch is open, Q switch is closed, then the current passes this direction, means from starting to ending the current passes means true. If both the switches are open, then the resulting statement, the current doesn't passes, so we can say the combined statement is the false statement. We can remember this as by the wording, if both are false, the resulting statement is false. Any one of them true, the resulting statement is true. That is complete. We can discuss the Venn diagram for this dissection. Let here consider this one, P or Q. P or Q means P statement. This is the P statement. This is Q statement. P or Q means we'll get this is here. We can consider this as a union form. That is, in the only P accepted, only Q accepted, both is also accepted. That is nothing but this is both only true, only both doesn't happen. Means what? If both are false, then false. But so, next definition, implication. The combined statement, the combined statement with connectivity, if then, combined statement with connectivity, if then is called, if then is called implication. Yes, let us see here. This is implication, means the connectivity we can use if then. Let's consider P comma Q B. Let we are taking this B. Any statements, then let's consider here the implication, the P, it is denoted by P implies Q, defined as if P then Q, if P then Q. Let's consider one of example, X is even number, X is even number is a statement P. Next, Q is another statement, X square is divisible by 4, X square divisible by 4. Now let us consider here in this P implies Q, means if P then Q, if P happens then Q happens. That is, if X is even number, then X square is divisible by 4. Now let us see the result of the statement. X is even number, it is a true statement. Let's consider two statement. X square divisible by 4. X square divisible by 4 means we can write this is also true statement, because you can consider any number, even number. 2 square is nothing but 4. 4 square is nothing but 16. This is divisible by 4. This is also divisible by 4. That means X square divisible by 4. That means this is true. First statement true. Second statement is also true. If this is even number, this is divisible by 4, accepted, the combined statement we can write as a true. Now let us will discuss for the truth table of the implication. Truth table for is a statement. This is the best example for our students, to succeed in the mains examination in May. Now let us will discuss the first example. We work hard up to March. Every student work hard up to March. The first statement. Second statement is he continued the work till examination. examination. So the final result is he continued from 2 years up to the examination, March examination, and then he worked up to the examination. In the peak time also he worked hard. So the final result is he will get satisfied result. And the second one, so true and false. Second one is true and false. We work hard up to March, up to the March. He stopped working in these days because Corona effect. He stopped the working because he's not there in the college. He stopped working. Then is it possible of getting satisfied result? No. No chance. That is nothing but we have to work hard. That is nothing but we will not get the satisfied result. Next, we'll go for the next. He doesn't work in the starting. Up to the March, he doesn't work. Liberally he worked. He started working in ending days. That is last 2 months. That is these days. Even though he is not worked, but he passed the IP examination on pass 75% or 80%. But he started working seriously in this examination in the last 2 months. He may be satisfied. He may get satisfied result. And let us consider the last case. He doesn't work up to the March. He doesn't work till again in these years 2 months. No chance. That is nothing but he'll get. He doesn't expect the result. He can mark an examination. Luckily, he can mark. Suppose if there is a chance. Maybe satisfied result. He may be satisfied with the result. And then true. Both false. Then true. Then if true and false comes, then true to false. That is final result is the headed side, that is nothing but false, and false true. Let's consider the headed side true. The final result is nothing but true. Yes. Go for the next definition by implication. Let us again see this by implication. Just implication, we are changing just by implication. Now the combined statement with connectivity, which two statements connected by the connectivity, if and only if and only if, that is if and only if and only if connected, then that is called by implication. This is the combined statement is called by implication. P and Q are the any two statements. The by implication symbol, let's see here, two sides arrow will get two sides arrow, and defined as if, double if. Let's consider this one, if and only if. Then Q happens. If this work out from LHS to RHS and RHS to LHS. Let us consider the example to write the by implication. Two statements are given. X is an even number. Then second statement is x square is divisible by 4. P by implication with Q we want to write. P by implication with a Q means we can write, which means P double if. Just let's consider the if and only if, then Q happens. and if and only if x is even number, then x square is divisible by 4. Let's consider the first statement is true, second statement is also true, and the final result is, we can discuss it as true statement. We'll discuss that how the combined statement is true statement. We'll discuss in the truth table. Let's consider truth table for the bisection, by implication. First, see the implication. Already we discussed. See the implication by implication. P. Both are true. In the implication, this is true. Both are false. Again true. And this is nothing but followed arrow mark. That is nothing but I'll get arrow side headed region. And this is the final result we are getting in this case. That means we can say here, see, by implication means it happens from LHS to RHS and RHS to LHS, both cases. That means we'll get, consider here, LHS to RHS is true. RHS to LHS is also same. True to true we are getting, that is here both are true means LHS to true, implication true, and true to false. This is also Q to true. Q, this right side we are getting the true. Left side is also same result happens. Then the final result accepted. And see here, right side is we are getting false. In the by implication, right side is false result. In this case, left side is true result. Both are not matching. The result is we are taking as a false result. And third case, right side is true result. Left side Q to P is our left side result is false result we are getting in implication. That means we can say this is true, one case true, other case false, doesn't match us. So in this case we can consider false statement. See here in this LHS, this is P to Q means true, Q to P is also, yes, false means true, Q to P is also false means true. Both cases are true. Result is we'll get true. Once again, we'll discuss the by implication. Both are true. Then the final result is true. Both are false. The final result is true. And if any one true, one false, in that case, we'll get false. That is the final result of the by implication. The statement P is two sides are equal in the triangle. Second statement is, let's consider here, the triangle is isosceles. The triangle is isosceles. Q statement. Now implication upon this is, we can write P implies Q. P implies Q means we'll get if P, then Q happens. Then Q. If P, then Q. That is, if the two sides are equal, two sides of triangle equal, then the triangle is isosceles. The triangle is isosceles is the implication. Now we applied upon these two statements, applied the implication. On the implication, we have three definition conversions. First one, that is converse. First one is on implication, we can apply three conversions, and that is converse. Converse of this statement, this implication is, we can write the second statement as a first statement as a second statement. That is, given statement is P implies Q is given statement. Then converse of the statement, we can write Q implies P. Q implies P. That is, if the triangle is isosceles, then the two sides are equal. Two sides are equal. Go for the next converse, after that inverse. Inverse of the statement is, let us consider further implication. Applying inverse means it is nothing but simply application of the negation of the first statement implies negation of the second statement. Don't apply for the total negation. One of the student is asked, inverse of the statement means apply the negation on both sides. Don't apply the negation. This is here, negation of first statement implies negation of the second statement. That means we'll get here, the example is, conversion is, we'll get if two sides not equal, then the triangle is not isosceles. Triangle is not isosceles. Negation means apply the not, and two sides are not equal. Negation of P means, and the triangle is not an isosceles. The triangle is isosceles given in the second statement, not an isosceles in the second statement. We are getting negation of Q. Now we go for the contrapositive. Contrapositive. So see here, contrapositive is just for inverse, right reverse, means apply the converse for the inverse. That is, we'll get negation of Q implies negation of P is nothing but contrapositive of P implies Q. Contrapositive of P implies Q. That means in the inverse, second statement delta, that is triangle is not isosceles, then the two sides not equal. Since triangle is not isosceles, and the two sides are not equal. But once again, converse means for P implies Q, converse means Q implies P. Converse means Q implies P. Here in this two statements, one of statement is the triangle, two sides of the triangle are equal. Second statement is triangle is an isosceles triangle. This is the first statement, this is second statement. Now here in this, converse means second statement as a first statement as a second statement. Just write, they will get the converse. Inverse means simply we can write negation of the first statement and negation of second statement. And contrapositive means again for inverse, write reverse. That is nothing but we'll get converse apply for inverse. Converse of inverse is contrapositive. Table for P conjunction Q implication R. That is the combined statement with the three statements. Combined statement with three individual statements. Now let's consider here P, next statement Q, next statement R. Now to write the truth table for this, first prepare for P and Q, that is P conjunction Q, prepare it, and then go for the final result. Now P conjunction Q, to write the P conjunction Q, first of all complete this table first, that is we'll get all the cases true, true, true. Next, second case is true, true, false. Both two trues, one false. Next case. And next, we'll go for the true. This is false. This is true. Two trues, one false. Next, we'll go for the here. This false we are taking in the first place, two trues, and the next two statements. Next again, we are writing one true, two false. Next, we'll get false, true, false. Next, false, again false, true. Final, false, false, false. These we can calculate the number of cases by using permutation and combination, which we can learn in the second year. That is, P has true or false, means two cases we have. Q has true or false, two cases we have, and R has two cases. That is, total number of cases we can calculate it 2 to the power of 3. 2 power 3 means it's nothing but 8 cases will get 1, 2, 3, 4, 5, 6, 7, 8. 8 cases we got. Once again, see this one here. All 3 true, 2 true, 1 false, 2 true, 1 false, 2 true, 1 false. Next again, 2 false, 1 true, 2 false, 1 true, 2 false, next true, next all false. Now write for the combined statement result, P and Q result. P and Q means, first of all, here we want to write the conjunction. Conjunction means we can get here, we can write with the result by using the circuit diagram. That is, we'll get P, this is P switch and this is Q switch. We are connecting with connectivity here. Now P true, Q true, that is both are closed. True means closed. The P true, Q true means current passes through from starting to ending, that is true will get. Second, both true means we'll get the same case true. True and false. True and false. P true, closed. Q false, open. Current passes only up to Q, not for the ending. So doesn't passes means I can get P and Q is false. Next we'll go for the next case is P open, Q closed. P open, Q closed. Means we'll get the current doesn't passes from the starting to ending, means doesn't passes means false. So we go for next Q closed, P closed, Q open. P closed, Q open, means current doesn't passes, means we'll get false statement. Again, false true, doesn't passes. False false, both are open means doesn't passes. Both are open means doesn't passes. That means we can say for this is the result we are writing. Now we'll go for the final result. This is P conjunction Q, this is R. The final statement is P, this is implication to R. R side take this direction. P and Q, the two R. The final result is nothing but we'll get true to true. In implication, both are true means true will get. P, M and Q, 2 R. That is, we'll get here in this false to true. False will get headed side, goes to the final result. Again, false to true to false, final result is false. False to true, the final result is nothing but true. And false to true, the final result is, yes, we'll get true. False to false, if both are false, the result is true in the implication. False to false again, the final result true. True to false, the result is, yes, we'll get true. False to false, the result is true. Yes, here this is nothing but we can write the truth table, result of the truth table, result of the truth table. And there are another one more. This column gives the results of the special cases. Now another two more definitions we have. That is nothing but I'll get tautology, and second definition is contradictory, or fallacy. Tautology and contradictory or fallacy. In this is nothing but the combined statement. In the combined statement, result of the combined statement. See here, result of the combined statement. That is this result, this combined result. Yes, the total result. If all truths comes, then all truths. In this place we got false. That means suppose here instead of false, if it is true, we will get all truths. All truths, then that is nothing but the combined statement is tautology. And if we get all falses, then that is called contradictory. The combined statement is called contradictory or fallacy. These two are very, very, very important for the mains examination. Every year, 2 sessions, we are getting these applications, these tautology and contradictory applications we are getting. And these 3 parts, first part 1, part 2 and part 3 in the LOGITICS. Read the part 1 first, then go for the part 3 next, and then we'll see the part 2, then you can understand the topic briefly and perfectly. Part 1 first, part 3 next, and go for the negation properties. We can get perfectly the concept of the LOGITICS.